Hello there. I just want to go over some answers with you and kind of talk about inequalities and how to solve inequalities. Just in case you need a refresher, you'd like to just kind of see one more time how to do this on a video. I'm looking at page 282. This is lesson 5, unit 5 from the 7th grade textbook, volume 2. And I'm just going to go over these problems right here. Keep in mind that inequalities will have many different answers because we're talking about greater than or less than. And we're answering the question, what values can I put there for x? Like what numbers can go right here to make this a true statement? So that when I multiply by 4, the solution of the answer is something greater than 12. So we would solve this the same exact way. We follow the same processes, the same operations, same properties of equality that we saw with equations. So we would divide by 4, and we would use the symbol that x has to be greater than 3. Does that make sense? So if we go ahead and graph this rather, put a 3 on here somewhere, we're talking about numbers that are greater than 3. So what numbers are greater than 3? There's a 4, 5, 10. 10's up there somewhere. So let's just pick one. Let's pick 5 and see if this is true or not. 4 times 5 is in fact greater than 12. So yes, we're correct in that. Let's go ahead and do our letter B right here. And so we have x divided by 4 is less than or equal to negative 12. And so in this case, when we solve this, we would multiply by 4 on both sides, multiply by 4, multiply by 4, and we end up with x, same symbol, less than or equal to, and then we have a negative 48. And so here we have a solid circle right here because it's equal to, and we are looking for numbers that are less than negative 48 or equal to 48, negative 48. So if we just picked a number, like let's pick negative, something that we can divide by 4. How about, let's pick a number over here. Let's pick an incorrect number, something way down here. Negative 40 is down here, right? That's in the incorrect zone. So if I tried negative 40 here, it should be incorrect. So negative 40 divided by 4 is negative 10. Is negative 10 less than or equal to negative 12? No, it's not. It is greater than negative 12. So we are correct in our graph is correct because we checked an incorrect answer and it was indeed incorrect. So we know that we are okay. Let's go ahead and do letter C. Okay, letter C is going to be an example where we see kind of the difference, the twist, I guess you could say, the new thing that we're learning with inequalities. A little bit different than an equation here. Here we solve it the same exact way. In fact, we're going to be dividing by negative 4. Divide by negative 4. And now, if we went ahead and just solved this and used the same symbol, our answer would be negative 3, right? If we use the same symbol, greater than symbol, and if we looked at this and said, okay, my solutions are greater than 3. Let's pick one of those. Let's pick 5 out here, okay? And then multiply negative 4 times positive 5 is negative 20. Is negative 20 greater than positive 12? No, it's not. So we know that there's a mistake somewhere in our reasoning and in our solving of this inequality right here. And as we saw in the examples, when we divide or multiply by a negative number, the sign will do this right here. We still have x over here, we still have a negative 3 over here, but the symbol is less than. So if we check this, all right, we have an open circle, we're looking at numbers less than negative 3 over here. So let's just pick like negative 5. Negative 5. So negative 4 times negative 5 is a positive 20, and positive 20 is in fact greater than 12. So check. We've got it correct. So this is the one rule right here that's kind of new. When we divide or multiply by a negative number, that symbol will flip around right there. Okay, so let's jump over to some two-step inequalities. I'm just looking at page 292, I think this is. Check that out. I think it's 292. And I just want to do a couple of these problems with you. Number 4 right here, we have a diagram to help us understand this. he runs 3 miles and he wants to run more miles. Here's the more, we don't know what that is. So we see 3 plus some unknown amount, x or whatever you want to use for that, is at least 12 miles. He wants to at least run 12. So he wants to run more, or he's okay at 12 miles, but he wants to run 12 or more miles. So this is what the inequality will look like. Let's go ahead and solve it. Subtract 3, x. In this case, do we need to flip the sign? No, because we're subtracting. We're subtracting. Only when we multiply or divide would we want to flip that sign. So x is greater than 9, or could be equal to 9, and let's just double check that. Let's pick 10. All right, let's pick a number greater. 3 plus 10 is 13, and 13 is greater than 12. So that does solve the equation. That is a solution right there. Let's do number 5 right here. Let's go ahead and just solve this. This is 2 steps, so let's go ahead and subtract 4, end up at 6.5x less than 5. Now we divide by 6.5 and divide by 6.5. So x is less than 5. I believe that's correct. So do we have to flip the sign? No, because we're dividing by a positive number. How about this one right here, Thomas? Now this one we're reading. We have to create and write out an inequality. He has $1,000. We know what his plane ticket costs. So 348 is his plane ticket. 348.25. That's his plane ticket. He stays 5.5 days. We don't know how much each day is. That's our question, right? How much is each day? So we'll just define our variable here. So x is the cost per day. How about that? For one day right there. We know how many days it is. 5.5 days. So we need to add on 5.5 days. 5.5 days times the cost of each day. And he's got $1,000 to spend. Does he have to spend all of it? No, but can he spend more than 1,000? No. So this is the symbol. He can spend less than it, or he can spend up to and including 1,000. So that's this is what it will look like right here. And we solve it just like this. Okay, so we have our solutions right now. His cost per day could be anything less than or up to and including 118. Let me get that right there. $118.50 right there. That's our solutions. All right, let's go ahead and do 7. That'll be our last one for the day right here. All right, let's go ahead and solve this. Notice that 12 minus 3/5 x, we could write 12 plus negative 3/5 x. So in our minds, I'm just kind of keeping in mind that that's a negative 3/5 x right there. So we're going to begin by getting rid of the 12 right here. So we have negative 3/5 x. So that subtraction symbol really stays with the 3/5 x and becomes a negative symbol right here. And of course, we're not flipping our symbol right there because we're simply subtracting 12. And we get 27 right there. So now we're going to multiply by the reciprocal, multiplying by negative 5/3 and multiplying by negative 5/3. It does not matter. This negative symbol doesn't matter if it's up there with the 5. You could put it down there with the 3, or you could put it out front like you see right here. They are all equal to each other. As long as there's one negative symbol somewhere in that fraction, we're okay. So let's go ahead and do this in our heads. 27 divided by 3, that's going to be the first thing I do. And then I'll multiply by negative 5 and get negative 45. We are, let me go ahead and put that in there first, negative 45. And we are going to flip that sign because we have multiplied by a negative number. So x is any number less than negative 45. If you pick that and put that in our inequality, it will be true. That's it. Let's call it a day. Take care.